Uh, Hello. So welcome back. Um, so to continue with to go on with um our question about uh, the solving for the solving for interest rate. Well, we had to go through um, basic, properties of exponents in the previous video. Um, just a couple of more things, just to be, you know, uh, just to clarify and to just to shed some light on, what you just uh, memorized by rote. For everyone would understand, everyone would basically know that anything raised to zero is anything raised to zero is what? One. Now, some people might say zero. That's um, anything multiplied by zero is zero. But this is why it is fundamentally problematic. When people just when they make you just um, memorize by rote uh, without logical and deductive reasoning. Now, and critical thinking. Now, the reason that anything raised to zero is one, I'll explain that, uh, using one of the properties that we used. So there's something that bothers me. So let me clean that out. Okay. Now, why? Now, first of all, using these properties, right? One of the properties was this. X to the a, x raised to a, times x to raised to the b is xa plus b, right? Isn't that right? So let's try that. So suppose, you have f squared. I'm sorry. F squared then times x to the negative 2. Okay. By the way, you all know what x to negative 1 is. What is x to negative 1? Raised to negative 1. It's the reciprocal, right? It's 1 over x. Okay, that means x to the negative 2 is 1 over x squared. So then we can rewrite this. But by the rule, right? By the exponents rule, this will be x squared plus, right? Minus 2, right? Which is then, of course, everyone would know is x to the 0, right? But then why is it 1? Now, to answer that, right, let me write it back here. So we all know x squared times x to the negative 2 and x to the negative x, that's x squared times 1 over x squared, right? Using this rule. Then what is this? They cancel out, right? This is 1 because it cancels out. Makes sense? They cancel out, so it's 1. Therefore, x raised to 0 is 1. Anything raised to 0 is 1 by the same, okay? All right, so enough of that. So now let's bring us back to, let's bring ourselves back to this question. So we were stuck there. We were able to isolate all the way up to 1 plus r raised to n is FV over PV, or P, right? Now, you understand P is also called, principal is also present value, right? Now, remember, to lose this exponent, right, it's x raised to n, then to make this, to lose this, to make it 1, what do you need to do? You will need to raise it to 1 over n, right? Makes sense? Taking the nth radical, which means, I will have to write this all over again, but we are going to raise it to 1 over n. Okay, over n. And then think about it. If you raise, this is an equation, that means the left-hand side is equal to the right-hand side. So to keep that equality between the two sides, then whatever you do to one side, you must also do the same to the other side. So I raised the left-hand side to 1 over n. So what does that mean? You'll have to raise the right-hand side also to 1 over n. Right? Makes sense? Then what's going to happen to the left-hand side? N and 1 over n will cancel out. So, I mean, this is not a difficult thing, but, so I'm going to simply, whatever is in the parenthesis, right? I'm not going to rewrite it, but, but this means, the thing in the bracket, right? The thing in the parenthesis. And we know it cancels out, so it's going to become 1. And this will become 1. And the right-hand side, the thing in the parenthesis will still be, there. Now, I'm going to bring it over here, right? So if I bring it over here. So in the parenthesis, in the left-hand side, now, only 1 plus r remains. And in the right-hand side, only the thing in the bracket remains, and the thing in the bracket is FV over P, right, or present value raised to 1 over n. Now, solving for R means, just isolating R in the left-hand side. What do you need to do? You'll subtract 1 from both sides, right? Or, transpose, move 1 to the other side. Then what does it become? FV over PV, or P, right? Raised to 1 over n minus 1, right? But now, doesn't that look a little familiar? You saw this somewhere before, right? I hope you haven't forgotten. I mean, it wasn't that long ago, right? You saw this in the when? In the first topic, ROI. And what was it? In ROI, there was a name for this. What was that? It was called the geometric average. Wasn't it right? What was the formula for geometric average? At the time, we used, G, growth rate. And I told you the growth rate is, it's basically a return, right? Rate of return, average rate of return. But when there is only capital gains, right? No incidental income. In other words, only in scenario 1, growth rate is exactly the rate of return. But in scenario 2, growth rate and return are different, because in scenario 2 there is not only capital gains but also additional income, right? Incidental income. And remember, in that geometric average, the future value was expressed as P sub t plus n, and the present value was pt, right? P sub t, P subscript t, and over 1 over n, and minus 1. Remember that? Hence the geometric average, which is, and this is how the geometric average formula was derived. Because I've been telling you from in the first topic that there's a compounding going on, and when there is compounding, the average cannot, the growth rate, the holding period return can be annualized, but it has to be the geometric average. Why? Because of this, because it's compounding. And in compounding, we solve that basic compounding equation of future value equation for R. And then you come to this. And at the time, I couldn't show you how it is derived because you are not ready for that. But now you see how it is derived. Okay? So once you know these connections between different variables, right? You don't have to memorize anything. Some people ask me, Professor, do I need to memorize all the formulas? I mean, there are lots of formulas, and some people feel daunted and overwhelmed. It's too much. But look, smart people do it in a smart way. They don't just, do it by rote, right? If you understand how it is derived, how it came about, right? And if you can replicate the process, then you don't have to memorize anything. Now, our next question, then our next question is, uh, so our next question is then, I hate to, since there are 4 variables, right? First, okay, let me use this. Let's quickly. We know there are 4 variables, right? Why? First, future value, that's one variable. Then present value, that's another one. R, that's another one. N is the 4th one, right? When future value is the unknown, we find the future value this way. And when P is the unknown, we find the present value this way. When R is the unknown, we find R this way. Our next question is then, how do we, what if we don't know N? Well, we will solve for N later, but then let's go to an example, right? Let me stop sharing this and go to share application. Let's go to Excel. Okay. So our next question is, next example is, okay. Let's find R or APR, right? And then let's find also present value, P, right? So in this example, this is the example we already know. Future value is this, 13,000, and APR is this, right? Time is this, right? Compounding frequency is quarterly, right? This one, annual, right? Then, what is the present value? Present value is future value, right? Simply, it's a future value. Discounting, right? 1 plus APR. It has to be R, but R is what? APR divided by M. You have to adjust that annual rate by compounding frequency, right? And then raised to 5 times M, right? All right. Then what do you think? What do you think we're going to get? We're going to get exactly 10,000, right? This one is not exactly 10,000. Why? Because, let's see, because this is probably pointing to the wrong, what is this pointing to? E2. Oh, and in E2, E2 is actually, annual compounding. So let's find this should have been E4, right? If it is this should have been, in other words, not E2. Right? If the future value was, this 13,468, and compounding was quarterly, then it will be exactly like this. And this is annual compounding, so let's see what's in there. It's pointing to E3, which is not the case of annual compounding. It should be this. Okay, then if I find, you don't have to solve it again. You just simply, drag it down. Then it's not the number that was copied, it's the formula that was copied. And because anyway, D13, which is, 1 doesn't affect anything. It's, innocuous, but it's better to keep the formula uniform and consistent. Okay. Now, so that was, the example of discounting. Let's go to uh, let's go to a example of finding R rate, right? So here, looks like um, you have $10,000 today, and you want it to be in 5 years, you want to grow it to $30,000. Okay. In this case, it's just a given number. This is not the given number. You see, the formula is filled in. So once we have the correct um, rate there, this is going to look different. But let's do this first, because when this is the unknown, when this is the unknown, all the other variables must be known, right? The only we are because we are solving for the unknown, right? To solve for the unknown, other inputs must be given. So here, according to our formula, right, is future value over present value, right? And then raised to 1 over n. But here, what is n? N is t times m. M is not given, but if we, even though m is not given, we build it, right? We build m into n, so that the n would be t times m. Then it can handle any situation. It can handle whatever the m may be. Now, t is in C16, and I would like to click in C16, but you can't. When the formula is the cell containing formula, and formula is showing, it's hovering over. I mean, it's covering C16, so you cannot click it in. In that case, you will just need to type it in, right? And then C16 times then D16. Okay, and minus 1. All right, now because D16, this column, D column is not filled in, it contains no data, Excel will automatically recognize it as 0. It may, and then it will show you, I mean, the way it is now, it might show you that it might, display error message, but, let's, no matter what. See, why? Because this is blank. So in this case, I'm gonna, let me try entering 4 there, right? There you go, we got that. Okay, so now, what if it is 1? Annual compounding. I would have to take this interest rate to get to, to triple your money, right, in 5 years. Now, let's keep it at 4. And in this case, this is what we want to solve for, right? I used some function called goalseek, but don't worry about it. We'll try a different. So let's make this equal to that. Meaning our M is, okay. Now look at this scenario. What does this mean? You have $10,000 principal, and in 5 years you want to grow it to 13,468. Okay. What should be the interest rate? What kind of interest rate will grow it to this in 5 years? Right? So this is actually not APR. This, what we found here is actually periodic rate, right? Because, so let's see if it is periodic rate. So if we can turn it into APR later on, right? So in here, we will copy this because that's the, and if it gives us 1.5, it's the correct one. Now, so I'm going to copy that and paste here. And I'm expecting 1.5% there. Voila, isn't it? So in other words, currently this is periodic rate, not APR, right? Currently, what is in here is the periodic rate. So when you build a model to solve the problem, you cannot just mindlessly, copy the labels from the previous problem. You'll have to make sure that what the label says really means what it means what it has, what it really does. So in other words, it must say what it means. So here, if you left it as APR, then you're wrong, because clearly this is not the annual interest rate that would take you there. Annual interest rate was what? It was 6%, right? And also remember because compounding frequency is 4, right? If I made it 1, you remember, if I set the compounding frequency to annual, then it was this, right? And then so actually to turn it back to annual rate, because all the rates must be expressed as annual, what do you need to do? All you need to do is just make an adjustment, right? In other words, if what I got there is a quarterly rate, simply by multiplying it by the compounding frequency, then you will turn it into annual rate. Okay, the annual rate here, in other words, what do you see here? From here to here, that was what gave you the periodic rate. Then if you multiply it by 4, because quarterly it is something, then if you multiply it by 4, that will give you an annual rate, right? Then I do the same thing here. copy that, paste it here. It's going to give you exactly 6%, right? Now, previously when I had just 1 there, then it was and it was showing 24% something, but that was not the same thing, because it's not like converting quarterly rate back to annual rate. It's like starting from the annual rate from the scratch, starting with the annual rate from the scratch. So it's a different thing. Now, but this checks out. I mean, we can confirm that we got it right by checking it with the original scenario. The original scenario is like this, right? In the original scenario, everything was known except for future value, right? But here, everything else is known, future value is known, and everything else is known, but APR. But then, if you solve for it, first, for periodic rate, and then making an adjustment to convert it back to annual rate, which is a very easy process, because anybody can understand if quarterly rate is something X, to convert it into annual rate, just simply multiply it by 4, right? Which is what was done here. But none of this is hard-coded, right? One thing you have to remember is you don't hard-code anything. You remember what hard-coding is? Actually entering numerical data into the formula. You don't enter numerical data into formula, right? Okay. All right. So that's it for this segment of the video, and I will see you in the next video. All right. Thanks for watching. Stop.